Hi everyone, Alvin Blocks here with a tutorial, an advanced scripting tutorial on C-frames. Really excited to be doing this one, and I'm just going to kick it off. So a lot of people think that C-frames are hard to understand. They are not hard at all. They're very, very simple. It's just that a lot of people don't understand them, which makes them hard. But the understanding is very simple of how they work. So in Roblox, if you want to move something, we're going to use a part, for example. If you want to move something, you have to change its position property, okay? So if I wanted to change the position of something, I would have to set its position to a vector3 value. And that vector3 value is made up of 3 numbers. And I'm using the InCommand plugin as a way to demonstrate this, so I can write code and easily show it to you. The plugin is available in the description for 125 Robux. I recommend it. So it's basically like a command bar. So if I want to position the block, I have to supply 3 numbers. Those numbers are X, Y, and Z. In Roblox, we have 3 axes. We have the X-axis, Y-axis, and Z-axis. When you click on a part, you will see, when you use the Move tool, that we have these arrows for each axis. So we have the green arrow, which goes up and down for the Y-axis. So that determines the position, the vertical position, so whether it goes up or down. We then have the X-axis, which is the red one, and that goes across like this. We also have the blue arrow, which is the Z-axis, and that also goes across, but in a different direction. So it's perpendicular to the X-axis. So we've got the Y-axis, which goes up and down. So 1 goes up and down, and we have 2, which go across, but they go across in different directions. So the X-axis is the red one, and that goes across like this. We also have the Z-axis, which goes across in a different direction, perpendicular to the X-axis. So these 3 axes, X, Y, and Z, determine where a part is positioned. Because in Roblox, we have something called the origin. So in every Roblox world, there is an origin position, and that is called 0, 0, 0, when the X, Y, and Z values are all 0. Now, to see the origin, you can go to View and click on Show Grid, and you'll see these 3 arrows appear. You can see where these arrows meet in the middle. That is the exact origin, the exact middle area of a Roblox world. It's not the middle of the base plate. If I take away the base plate, you can see it's still there. But the origin is this location here. And just think of it as like kind of like the middle of the game world. So the base position. So let me just bring the base plate back. If I was to set the position of this part to be 0, 0, 0, the middle of the part, so in the middle here, so inside of it, if you think inside, if we just, let's try and make it semi-transparent. So imagine that if this is the middle of the part, that little orange block in the middle of it, just imagine that that is the middle of that part, right? If you're thinking about it, that is the middle. If you go inside, it's there. So when you position something, it's actually the middle. The position is being taken from the middle of that part. So if I was to change the position of this part to put it to 0, 0, 0, and let's run it, you can see that it goes that now the origin is in the middle of the part. So when you position an object in Roblox, it's being moved and placed so that the position value that you give is where the middle of the part is going to be positioned. So obviously this part is now at the origin, and if we take away the base plate again, you can better see that it is in the middle of the origin. So the middle of the part gets positioned, and so we've got a little bit going under the base, a little bit above it, etc. But what you need to know is that when you position something in Roblox, those 3 values, the X, Y, and Z values, if you look closely here at this position property and don't take your eyes off it, when I move, I'm going to set the snap to grid to 1 stud. When I move the part away from this origin, you can see I'm moving the X-axis, so the X comes first, and it is decreasing. So as I'm moving it further away, it is decreasing, okay? The more times I move it, the more studs I drag it away, that X number is decreasing. If I was to move it in the other direction, let's put it back at 0. If I was to move it in the other direction, it would start increasing. So we can see as we move the X-axis, the X number is either going up or going down. So it goes positive when I move it to the left of the origin. Well, left in this terms, because obviously it could be different depending on which way you look at it. But as I move it left, it's increasing. As I move it right, it's decreasing. So it's telling us how many studs away we are from that origin. Now, if I was to move it up in the air, it starts increasing the Y value. And if I was to move it down, it would decrease. Okay? So if I move the Z-axis, you can see that the Z value is changing. So really, what's happening here, and I forgot to move the base plate back, so give me a second. There we go. So you can see that the position is basically telling us how far away we are from this origin point. So what the position value tells us is that we are 37 studs on the X-axis away from the origin. So we are 37 studs away in this direction, away from the origin. So let me try this. So we are 37 studs away from being back at that origin on the X-axis. But if we were to look at the Y-axis, the Y goes vertical, we are 19 studs away. So to get back to the ground, we would have to go down 19 studs. Okay, and looking at it on the Z-axis, which also goes across, just like the Z, but in a different direction, to get back to the origin, we would have to go 18 studs forward, like this. So, well, backwards even, because we've gone forward already. So we would go back 18 studs in this direction, just like we would go back 19 studs in the Y, and we would also go back 37 studs in the X. Okay, so you can see that the position value it's not telling us, well, it is telling us where it is in the world, and it's using the origin point as a reference. So the origin is our reference, and by using it, the position value tells us how far away we are from that origin point, but also we can now use that, because all other objects in the game are using the position, we can use it to find out where things are in the Roblox world. So the position, you can see as you move it around, it's constantly changing, but really all it is it's telling us how far away we are from the origin on each axis. So what it's telling me is to go back to this origin here, we need to go backwards 156 studs. So I will now demonstrate this to you with code. Okay, so if I just go here and I take away 156 studs from its current position, because it's currently 156 positive studs away from the origin. If I go and now take away those 156 studs, oh, I need to change the name of it to block. There we go. You can see that the origin, the X value is now 0. So it is at the origin in terms of X, because X is 0. We now just need to edit the Y and Z values. So now, if I just take away 142 from the Z value, look, it's taken it's moved it backwards by 142 studs, and it's brought us back to the origin. But you can just see it is actually 2 studs above the origin, so we now need to just take away those 2 studs. And now it is back at the origin. So you can see I've just proven to you that the position value is just telling us how far away it is from this origin point, but we can use it to work out where things are in the game world. So that is what position is. And really, it's not that complicated. It is just 3 numbers which tell us how far it is away in each direction from this origin point, and together those 3 points construct a position value. And you can, and by the way, it's measured in studs. So when you say vector3.new 0, 2, 0, it's taking away 2 studs, and a stud is if you set the snap to grid to be 1 stud. This is the increment that it moves by. So that's a stud, and you can see the size of a stud on the base plate. That's a guide. So that is what position is. Position is just telling us how far away is an object from that origin point of 0, 0, 0. Now, what is CFrame? Well, CFrame is pretty much the same thing. If I wanted to set the position of an object, I could say game.workspace.block.cframe equals no, you'd have to say CFrame.new, okay? And I'll explain why. Because it's a CFrame, it has to be a CFrame data type. But you can put a vector3 inside of here. So if I wanted to say 156, 156, 156, and click run, it moves up into the air over here. Okay? I could also say 156, 156, 156, like this. It would do the same thing. Look, if I move it, it puts it back here. So what it's done is, because CFrame contains both position and rotation, it has set the position of the object, but it has given it the standard rotation, okay, of 0, 0, 0, because we have not told it the rotation. We've just given it a position. But if we wanted to give it a rotation, we could do that. Okay, normally, if you wanted to give it a rotation, you'd first have to set the position property, and because you can't set rotation with position, you'd have to set the orientation afterwards. But a CFrame just combines it together in one. Let me show you. So, what if I wanted to position this block so that the face is looking at the bar? Well, if I try to do that, I could say game.workspace.block.position equals game.workspace.bar.position. Okay, and then we will just add on, about 20 in the X direction. Let me just show you that. So that it is to the left of the bar. But you can see the face is not facing the bar. We want the face to be looking at the bar like this. And so we haven't been able to make that happen using our script, because it makes it face. It doesn't alter the orientation. If I set the orientation of the part myself like this to be looking diagonally in this direction, and then I set the position, it has not changed the orientation that I set, because position does not alter the rotation of a part. Only CFrame can when you want to position something. So how can I do this? Well, let me show you again. Let's put the part in our rotation like this. I want it to be looking in the opposite direction when it's moved over here. I want it to be looking at the bar. So I can say game.workspace.block.cframe equals CFrame.new, and what I can do is I can tell it the position where I want it to go. So it's going to be vector3 position. So it will be vector3, and the vector3 has to come first. So the position has to come first. So it will be game.workspace.bar.position, so the bar's position, with 20 studs added on in the x-axis. Okay? So that's done. Can you see that it has set the rotation back to the default 0, 0, 0, because I haven't supplied one yet? That's going to come next. So once I've done the position, I can do a comma. And if I now supply another position value, for example, game.workspace.bar.position, this is the toward value. So the second position that you give in a CFrame, so we've got the first one here, which is the bar's current position with 20 added on in the x-axis to move it over here. So 20 stood to the left of the bar. That's the first position, separated by a comma. The second position is what it's going to look at. And magically, the CFrame is going to rotate the block to be looking at the second position. Now the second position is going to be the middle of the bar, because remember I said earlier the position value is taken from the middle of the object. So it would be looking at around about here, the middle of the bar. So if I run this, wow, look at that. The block is now facing the bar, and this isn't a one-time thing. If I was to move the block again and maybe put it over here, right? I want the face to now be looking in that direction. So I just need to run it again, set the CFrame once again, and boom. You can see it moved. That's because I still wanted it 20 studs in front of the bar, but it is still looking at this middle position of the bar, which is awesome. So let me show you a few more times. I can set its position to be what it is currently at. So game.workspace.block.position. If I didn't want its position to change, I just wanted its rotation to be looking at the bar, I could do that. And you can see now it is turned towards it. If I move it over here, it's moved over again. So it's looking at the bar. How cool is this? So this is just a function of the CFrame. It's built in, so that the second position that you supply is going to be the thing that it looks at. The first position that you supply is where it's going to position itself. So it's basically setting the position property to wherever you want it to be. The second position is where you want it to look at. So the thing it's going to face. So it's going to face that position. It's not going to face the block. It's going to face the position of the block. Okay. So that is how you can set a block to be looking at something. Okay, because a lot of people, they want to position something, but they also want it to be looking in a certain direction. So that's one way of doing it. You can also edit the rotation yourself. Let me show you. So you don't need that second position all the time. If you just want to set the position of an object, you can do that. So I could set the CFrame. So firstly, I'm going to position it to be, actually I don't need the vector 3.new. We can just put the position in here, so 10, 10, 10. So that will be 10 studs away from the origin on all axes, so X, Y, and Z. So if I run that, that will put it over there, just above the origin, and 10 studs in each direction. But if I wanted to rotate the part, I could multiply it by CFrame.angles. And when you multiply by CFrame.angles, you need to supply 3 angles in degrees, so an X, Y, and Z. Because once again, if you use the rotate tool, you will see that we have 3 axes. You can rotate it on the X-axis, on the Z-axis, and on the Y-axis. Although this time, the Y-axis doesn't go up and down. So you can just think of it of 3 different axes in 3 different directions. Anyway, let's reset that, and let me show you how you do it with the script. So if you're not familiar with angles or mathematics, you may know, well you won't know, but there are 2 ways to give an angle. You can give an angle in degrees, so that's the most likely one that you know. So you can do 90 degrees, whatever, however many degrees really. If I wanted to do 114.8765 degrees, you can do that. So you can supply an angle in degrees, but you can also supply an angle in radians. Okay, and I'm not going to get into what radians are, but they're just another way of measuring an angle. And so it's an easy way to, basically, when you're using CFrame.angles, you have to supply the angles in radians. Now, if you don't want to use radians, and because you probably don't know how to give a radian, and because a radian is a complete different scale, you can give your angles in degrees, which is what we want to do. But you have to convert them into radians, which is why we use the function built into Roblox called math.rad. So we need three of these for each axis, don't we? And so if we want to give the angle in degrees, we just put the angle in degrees in the brackets, and it will convert it. So if I wanted to rotate this on the x-axis, not by 90 degrees, let me set the orientation to 0, 0, 0. If I want to rotate this 90 degrees, I could put 90 in the x column. I'm going to put it in math.rad though, so it converts it into a radian. And now if we click run, Let's go to the output. Number expected got no value. Oh, my bad. So if you're not going to use the others, just put 0. Or you could put 0 in the math.rad. It doesn't matter. But because I didn't give a number to the math.rad function, it didn't work. So there we go. It has rotated 90 degrees and positively. So it's rotated 90 degrees positively. If you wanted to do it in the other direction, you would do minus 90. And where's it gone? There it is. So that has rotated it 90 degrees negatively on the x-axis. I'll show you again. So every time I'm running this, it is doing it, it's resetting it. So because we're firstly setting the C-frame and then we're moving it backwards 90 degrees, it's going to give the same one each time I run the script. If I wanted to keep on rotating, I could say, instead of giving it a new position, I could say game.workspace.block.CFrame. So it's current C-frame, which keeps the rotation, by the way, because the rotation is handled by the C-frame. And because in the last example, I set the position, I set a new C-frame, it reset the orientation. But in this example, because I'm using the current C-frame, which will take into account the current rotation of 90 degrees on the x-axis, and also the current position, if I run this again, you can see it's now on this this side, and if I run it again, it's on the bottom, and if I run it again, we're back where we started. So you can put any old number in here, but it won't make any sense what's happening because this is a radian. So if you want to do it in degrees, say you wanted to now rotate it on the y-axis by 180 degrees, you'd put that in math.rad, and it is now rotating 180 degrees. And you can see, if I was to rotate this normally, there's 90 degrees, there's 180 degrees, there's another 90 degrees, so that's 270, and that's 360 degrees, so we're back where we started. So that is CFrame.angles. That's how you rotate a C-frame. You have to supply it in radians, but if you don't want to supply it in radians, you can use the math.rad function, which will take your angle in degrees and convert it to a radian. And I will prove that to you if I go down here and I print out math.rad 90. It gives us 1.57079632679949 radians. If I go to Google and I do radians 2 degrees, and let's put in what it gave us, and it's given us 90 degrees with a little bit of rounding error there, but not to worry about. So basically 90 degrees, 1.5707 radians. You don't need to remember that. Nobody, I don't think, ever uses radians. We just use degrees because everybody knows what degrees are. 90 degrees is going to be, you know what's going to happen if I rotate this 90 degrees. Yeah, the face is going to be on this side. Boom, as expected. So that is how you rotate a C-frame. But what I want you to take away from this is that if you wanted to rotate something with a position, right, you would firstly have to go game.workspace.block.position equals vector3.new 10 10 10 game.workspace.block.orientation equals vector3.new 90 0 0. Let's run that. Okay, there you go. Now I've just managed to do that with C-frame. One property is controlling those two. You may be wondering, what's the point in C-frame when you can just firstly position an object and then rotate it? Well, C-frame, much easier, and it's very, very, very easier if you then want to take its current orientation and rotate it even more. It's just much easier because C-frame, it will update both properties for you, orientation and position. But also, C-frame has some really handy functions built into it, which are useful, very useful, and I'm going to show you some of them now. Okay, so the first one I want to show you is called Lerp, so linear interpolation, and you can see that if you have 3 parts, let's create 3 parts. Let's do what the example is showing us. So let's see, we've got 0.1 and 0.2. So we'll just call this P1 for 0.1, P2 for 0.2. What if we wanted to position the block, or C-frame the block rather, in the exact middle between these two parts? Because, I'll move them over here as well, we've got a diagonal line. We have got a diagonal line between the two positions. If you imagine these are the two positions of each part, here and here. How do we know the exact middle? You know, is it here? Is it here? Is it here? How do we know? Well, thanks to the CFrame Lerp function, we can C-frame this so it is positioned and rotated in the exact middle in between them. Let's go back to the example and have another look. So I'm going to set the blocks C-frame, and then you just need to pick one of the parts. It could be P1 or P2, it doesn't matter, just one of them. So game.workspace.p1, get their C-frame, and because the C-frame has functions that we can now use, we can use the lerp function, so lowercase, and inside of here, if we go back to the example, we can see it takes two arguments. The first argument is the C-frame of the other part that's going to be on the other side, which you want the block to be in between, so the other part, and also the percentage, and I'll explain that to you in a minute. So the other part is going to be P2, so if you used P1 over here to begin with, the second one would be P2, so game.workspace.p2.cframe. And they're C-frames, yeah, they're not parts that we're using here, we're using their C-frames. And then the second argument is where should the block be placed? So if we go back to our example here, if you want the block to be placed in the middle, you'd set it to 0.5, because 0.5 would be here, 1 would be here, 0 would be here. So if you wanted it to be about here, you'd probably say about 0.25, wouldn't you? So I'm going to say 0.5, because that's half. Now if you click on run, boom, it's in the exact middle between them. And because it's C-frame, it deals with rotation as well. If you click on, sorry, not rotation. If you move the part upwards, it's going to make sure it's in the middle as well on the y-axis as well. So if you were to draw a line, you know, from this part to this part, yeah, that's pretty much bang on, isn't it? The part, well, it is exactly bang on. It's exactly now in the middle, equidistant to each point. So that is just one of the useful functions that comes with CFrame. You wouldn't be able to do that with position, but because CFrame, you know, is more advanced, it comes with these functions, you can start doing this sort of stuff with it. So like the example says, if you wanted it to be placed 70% of the way away from the other part, you would say 0.7, and that's why, you know, one of them has to come first. If you wanted it the other way around, you'd just change P2 to P1, like that. Okay, so very, very cool function there. I'll show you a few more now. In fact, I will not. I will leave that for a future video, because also I want to show you two world space and two object space, which will be coming in a future video, which is useful for things like item placement on a grid, on a base, so you can save it and load it relative to the base. So that will come in a future video, I hope. But one last thing I want to show you is how to add C-frames on. So let's say we wanted to move, we want to move the block 10 studs in front of where it currently is. So you could say game.workspace.block.cframe equals game.workspace.block.cframe, and you wouldn't say plus cframe.new. You would not say that, because remember, a new C-frame would have a new orientation, a new position. We just want to move it forwards or backwards or left or right. So we want to add on position. So to add on position, we use vector 3, because position is measured in vector 3. So we would say block.cframe plus vector3.new, and then you would put in the amount of studs on each axis. So you want to move it 10 studs along on the x-axis, you would go 10. Maybe you want to move it 2 studs up on the y-axis, and maybe you want to move it back 5 studs on the z-axis. And you may be getting confused with which axis is which, but if you look in the view selector, you can see it changes based on where your camera is. So we know that adding 10 to the x-axis would move it this way, over there. Adding 2 on to the y-axis would move it up a bit, and removing 5 from the z-axis, if we look closely, you can see the z-axis is actually going this way, so it would move it back like that. So let's click run and see what happens. Okay, there we go. So you can see that it is, every time I click run, it's going to move it away in that direction. And so it is moving up diagonally, really, if you look at it like that, because it's moving up, it's moving on all axes. But if I was to, let's move it back down here. Let's go back near the origin. In fact, let's go to the origin, nearly. If I was to just, if I only wanted to move it in a certain axis, I would leave the other 2 axes blank with 0. And you can see that it has moved 10 studs along positively in the x-axis direction like this. And it will keep on doing that as long as I keep on pressing 1 and adding on 10 studs with the vector 3. So that is how you add more on to a vector, to a CFrame. And so this is where the camera comes into play, because if you want to position the camera, you have to set its CFrame. And let me show you, for example, if I just drag in something from the toolbox, for example, a zombie, in fact, not a zombie because it will run away, a tent, you know, a barrel or whatever, and I want the camera to be looking at this, I could set, firstly, a part. I don't know where the part's gone. Part. Here we go. So, if I put a part here, and let's just imagine that this is called cam part, and let's anchor it and can collide, whatever, make it invisible though, and we have a second part, and we'll put it over here, and we'll call this part focus part. The names don't matter, but now if I wanted to CFrame the camera so it was positioned here and looking at the focus part, I could say game.workspace.camera. I'm firstly going to set its camera type to be scriptable. You always have to do that so that you can set the camera CFrame. Then I'm going to say game.workspace.camera.CFrame equals CFrame.new, and we'll say game.workspace.campart.CFrame. So I want the camera to be positioned here, yeah, but I haven't told it what to look at yet. Do I want it to be looking here, or up here? I haven't said yet. So if we were to do that, oh, my bad, it has to be a position, doesn't it? It has to be a position. You have to put a vector 3 position in the CFrame. That is my bad. So yeah, run this again. You can see it is just looking in this direction. It was just lucky that it was in this direction. But we can actually set the focus, the second position, to be game.workspace.focuspart.position. And then it's actually going to look in that direction. So if I was to move these items over here and do it again, you can see it's now looking over there. So that is how that's a brief introduction into camera movement and positioning, but you can see where this is going. So brief recap, CFrames, they take position and rotation into account, and it will, if you can either rotate the CFrame by saying, by using a second argument, a second position, which will be where it's looking at, or you can set the CFrame of something and multiply it by CFrame.angles, and you can give the angles in radians. So if I wanted to rotate by 90 degrees, like this, on the x-axis, I would be doing so, or I could just rotate by 10 degrees, or I could do it on a different axis, like this. So you can see where this is going. So I'm actually going to set this to game.workspace.camera.CFrame. So it's going to take its current CFrame and just keep adding on 10 degrees to it, like this. And you can see how it's rotating on that axis, on those axes, because it's rotating on the x and y axis. So that is some brief camera CFrame stuff. So yeah, CFrame. It controls the position and rotation. So it's a representation, a data type of position and rotation in one. So you can set a CFrame and it will be a point with rotation and position. And there are also some useful functions for CFrame, one of which we've looked at today. We'll go into some more in a future video, you don't need to know them yet. But all you need to know is that CFrame is a data type in Roblox, similar to position, but it also can control the rotation of an object. And by the way, the CFrame property isn't visible in the properties window, okay? It is there. Well, I mean, it is a property, but you just can't see it. But you can see the changes it makes to the orientation and the position properties. Okay guys, I know we're nearly at the end of the tutorial, but I just remembered one last thing that I have to show you, which is really awesome with CFrames. It's called LookVector. So if we think about a part CFrame, or any CFrame, it's going to have a LookVector. It's also going to have a rightVector and an upVector. You may be wondering, what are these? Well, let's imagine that this is our CFrame. Okay, and well, the LookVector is basically a unit vector, which means it's a direction with no magnitude. I think it's no scale basically. So it's not like it's got a set distance, but it's pointing in the forward direction, and the forward direction is you can tell it's the forward direction because this surface here of the part is called the front surface, and you can see in the surface window it will be there. But the LookVector is the forward-facing vector, so the direction, the forward-facing direction of that part of that CFrame. So if you were to take the LookVector and set the CFrame to be the current CFrame plus LookVector times 10, it would move it 10 studs forward in that direction. So let me show you. So game.workspace.block.CFrame, and we're going to set it to its current CFrame to keep the position and orientation. But then, what if you want to move it? So let me give you an example, right? Of course, you could move this block forward by adding on, like we did earlier, vector3.new and the amount of studs. But it gets quite hard to do that when it's rotated in a funny way. So you don't know the exact amount of studs to move this forward like this in this direction. It's not, it's a very complex vector3 value to move it forward in this direction. So if you just wanted it to keep moving forward in this direction, like a bullet would do, you can get its LookVector. And this is a great example, actually. The LookVector is going to be in this direction of the blue arrow. It might not be the blue arrow in all cases, but it's just because this is the front surface. If you see here in the block, front surface. So the LookVector will always be coming out of the front surface. And so what I can do is we can get the block's current CFrame, and we can add on. We're going to add on game.workspace.block.CFrame.LookVector. So I'm doing lowercase l and uppercase v, but I don't think it matters. So you're adding on the LookVector because it's a property of the CFrame. You can't just say block.LookVector. It has to be block.CFrame.LookVector because it's a property of the CFrame. So we're adding on, if you think about it, this is just a position. So it's a vector3 position value. So we're adding on this position. And if you do that, because it's a unit vector, I think the scale of it is 1, so like 1 stud. So it's going to move 1 stud in that direction. So you can see it's moving like that. So if you wanted to increase that, so if you wanted it to go further, you could times it by a number. So you could times it by 10 if you wanted it to go 10 studs in that direction. And look, it does. So it's going in that direction because the LookVector is basically the direction of this arrow here, and it's going to keep moving in that direction. But imagine that the arrow is only 1 stud, and so if you want to go further, you have to times the LookVector by a bigger number, and you can see off it goes. Now there's also a negative, so to get the opposite direction, you could just do negative game.workspace.block.LookVector, and it will start coming back the other way. And there's also there is also an up vector, and that vector comes out of the top of the part, or the top of the C-frame, and let's change it to say up vector. Up it goes, up in the sky. You want it to go down, you just change it to negative. So there's no down vector, because you can just say negative up vector, or negative look vector. So let's go back to that part. There is also a right vector. Like this, and that will, let's just change that to 5. So that is sending it to the right, and I know it looks to the left on my side, but it's because the right surface is here, and if we look at it from this angle, it is going to the right. So if you want it to go to the left, you do a minus right vector, and it's now going to the left. So can you see what's happening here? So if you think about it, the look vector, up vector, right vector, they're just the direction. So it's telling you the direction, and then you multiply it by an amount of studs for it to go in that direction by that much. So the scale of it, of the right vector, is, I think it's only like 1 stud. So if you think about it, the right vector will only be 1 stud, and the up vector will only be 1 stud. So, and the look vector, which will be going out of the front, will only be 1 stud. So if you wanted to move it 10 studs, you'd have to take the look vector and times it by 10, so it goes 10 studs out. I'm not too sure on the specifics of that, but you just think of the look vector, right vector, up vector as directions. So it's telling you which way it will go, and then you multiply that by a number, it will travel X studs in that direction. Okay, so the look vector is the forward direction, and that's taken from the front surface, and it's going to move in that direction. The right vector is taken by the right surface, okay, and the up vector is taken from the top surface. So that's all I'm going to do on C-frames for this video. Hope it was useful. If it was, please share it with a friend. Share it, wherever you can, to support the channel. As I've said, subscribe, like the video, and I'll see you in the next one. Cheers for watching.